Okay, welcome to the next set of slides. I'm excited about this one because do you remember that fancy example that I gave at the very start of class with all these cool different things making that counter? We're finally going to learn enough to make that ourselves now. Okay? So the topic is objects and classes. It's a very interesting topic and it's very fun. We'll get into object-oriented programming, and so eventually you'll be able to understand this meme and the other one that I put later in the slides. So with that, let's get started with this thing called structs. And what I want you to have in the back of your mind is data. We are wrangling data in this set of slides. Okay, so a struct is short for structure. And normally we put the word data in front of that as well. So it's all about the data right now. And then it'll become all about the data and the operations on the data. So structs, all about the data. Let's get started. Okay, so we want to make our own types. So a struct is, let us continue. A struct is a data type of your own making. So you get to pick the types inside and the names of all the inner member variables. And I will give you an example. Don't worry, this will make sense in just a second. So a struct is a data structure. It's a way of organizing a bunch of different kinds of data. Potentially different kinds. And each element inside the data structure has a name. So I'm going to give you an example on the next slide, but let's think of a few. Let's see here. Like, for example, if you're going to write a program that stores a bunch of student information, maybe each student, the data that corresponds to a given student is their name, first name, last name, their student ID number, maybe their date of birth, and what level they are, so like freshman, sophomore, things like that, class level, number of units taken, things like that. So this would be enough maybe for your particular program to represent all that you need to care about for a bunch of students, and you can keep these all close by each other. The idea is all of this data is in one big package. And so you get it all at once in a sense. And we're going to make that very clear right now. So here is an example of a struct that you might use in your program. It's called point. So a point, let's pretend it's a two-dimensional point. So a 2D. Oh, that's a bad D. A 2D point is made up of an x-coordinate and a y-coordinate, and usually you just keep those both around all the time. Right? They come in a package. They come together. You never want to separate them. You can't have a 2D point without both an x and a y. All right? So there's no separation there. Let's make sure this is still working. Yeah. So the idea is, let's make a data structure. Let's make a struct that packages together the idea of a two-dimensional point. So it'll have an x-coordinate and a y-coordinate. And we're going to save them together, okay? And so the way we do that in C++ is we say the word struct, then we give the name, we call it point, and then some braces as if it were a function. But one thing you have to watch out for is that semicolon. That is necessary, and feel free to come to office hours and ask me about why it's necessary. It's a fun quirk of C++ and C, I guess. But you got to remember that ending semicolon. And then inside of the struct point are all the data values that go that you want to associate with a point. So we're going to have a double x and a double y, because your coordinates can totally have double values. Like if I wanted to store 1, 2, 1, that's fine. But if I wanted to store, I don't know, 3, 1, 2, 3, 4, I could also just as easily have stored 3 negative pi. So we definitely want to use doubles here. Okay? So that's what a struct gives you, and through the magic of it, when we declare this, we get a brand new type. Yeah. Trying to fix my typing. Which is really cool to think about. Like, we're making our own types. We had ints before, we had strings before. We just made our own. It's called point. And so we're allowed to say point p. Oops. Let's have a normal color now. We're allowed to say point p semicolon because we just made the point type through this declaration. And I'll give you a real example in code in just a second. But when we declare it like this, that makes space for values of our new type, which have inside of them x's and y's. So inside of a p is an x and a y that we can get at. So everywhere a point goes, an x and a y go. The x and the y, they live inside. Okay? So isn't that cute? And just like any other type, these things start out undefined when we declare them. Okay, so, oh man, this is fun. Let's do this in code now. So make dir lec 14, cd lec 14, vim, I don't know, point struct. That's cpp. How about that? So here's what we're going to do. We're going to define our point type. We say struct point, don't forget that semicolon, and then we say double x, double y. This declares a brand new type. Now we can make variables of this type. And get there, and they'll have x's and y's associated, or inside of them. Okay, so now in main, I can say point p, that's my first point, point q, and what I've just done is I've made space in memory for one point, which really is, deep down, the way we defined it, 2 double values. Okay? So we have in here a point is defined to hold 2 doubles, x and y. So every time we make a point, we get an x inside of it and we get a y inside of it. So this line corresponds to this, and then point q makes another one. It makes a q. Inside of that holds an x and a y. Okay? So, this is all so exciting. Let's move on for a second, and we'll continue this later, that program. So, a struct is the name of the type, okay? An object, so we know what structs are now. It's the type that we just made for ourselves, called point. An object is an element, is a value of a struct type. Okay, so when we say point p, or point q for that matter, we create, we say, a point object. Okay? It's just another local variable. But the object part has significance. Okay? The fact that it's a struct and it holds things inside of itself, other types, that's what we call objects in C++. Okay? There's more to this rabbit hole when we get to classes in just a little bit, but that's where I want to start us off. So when we say point P, we create a point object as a local variable. That's just another way of saying it. P is a value of the type point, or P is an object of the point type. Okay? That's all. Just another word. Don't get too caught up with it. Now we have fields and members. So the x and y, because I've told you that they live inside of every point. We have an x and we have a y that we can get out. The x and y that live inside each point can be called any of the following. A field, okay? You can call the x a field, the y a field. So, for example, P has two double fields, both of type double. Yeah, two double fields, one called x and the other called y. Alternatively, instead of field, you can say member variable, or member. I guess I've used lowercase here. So instead, you can say either field or member/member variable, one of the two. Okay, so P, alternatively, we can say that P has two member variables, both of type double, x and y. Okay, so that's just a bunch of terminology. And now I've told you that when we say point P, when we make this type for ourselves, it has an x and a y inside of it. When we say point P, and when we say point Q, we make boxes in memory called P and called Q, which hold those x's and y's. They have space for them. So it's like boxes inside boxes. How do we get at that x? How do we get at this one's x? They're separate. Each object has its own fields. Okay, so P has an x, and Q has a completely separate x. Each point gets its own. And so maybe if we somehow made these 42, 43, 44, 45, how do we get out the 43 so we can print it? What do we give like to see out after ... How do we get P's y? The y that's inside of P. And that's where this dot operator comes into play. So we say, if I want P's y, I say P dot y. That's like the apostrophe. Sorry, P dot y. Okay, and that's a bad looking dot. P dot y. Think of it as an apostrophe. Okay? To access a member variable / field, these are all interchangeable words, you say object dot field name. Okay? And you can access it to set it or to retrieve the value. So for example, we can say p.x. Oops, oh no. p.x equals 42. See out p.y. Okay? So now, this is fun. This is exciting because before, if we wanted to have 2 points that we wanted to store, like maybe we're trying to store a line or something, like we wanted this coordinate and this coordinate so that we could draw a line between them. If only I could draw lines. Like maybe this is P, this is Q, or something like that. Before we had structs, we would have had to do something like, well, I need to store the x coordinate of P, px. I need to store the x coordinate of q as well, and same with y, qx, qy. So I need to make 4 different double variables, and they're all separate from one another. I can get lost in all this notation. But the beauty of points is that they all come in a package. Before, we would have had to make a bunch of separate variables, which sucks. It's nice, structs are nice, because all the data comes in one big package. Okay, so that's what I want to say there. And so let's use these things now. Let's finally say this. P.x equals 42, P.y equals 43, Q dot, I don't know, x equals 44, Q dot y equals 45. And now we can print these out, okay? We can say, if I want to print the point P, I can say cout, parenthesis, P.x, comma, space, P.y. Close brace, new line. And I can do the same for Q. Okay, so let's watch this work. And what I just did, though, remember, is I instantiated P to hold these things, 42, 43, and Q held 44 and 45. Okay, so are you ready? Let's watch this work. Here we go, here we go. Oh man, isn't that cute? So we can use these dots to access the member variables, the little elements inside of every point. They have an x and they have a y. So when I say point P, I made space for P's x and P's y. All right? And we can instantiate those values. We can change them, just like that. This is a bit of a long way of doing things. I do want you to notice that we got some braces, we got some variables in a certain order. That's kind of like an array. So there is a faster way to declare and initialize any struct, okay? You can use this array-like notation, and you give the member variables in order, okay? Okay, so this sets, oh goodness, this always happens. One day I'll learn. So this sets the member variables in order. Because we declared x first, then y, the 44 gets set to q's x, the 45 gets set to q's y. And so, again, I just made this in a different way. Okay? Alright, and so that's, let me just give one last thing so that you see it both on the slides and in the code. So if the y came first, then this would be setting the y. But the way we declared the structure is that the x came first. Okay, that's all I wanted to say there. So that is the dot operator for points. And well, structs are your second option. If you want to return multiple values from a function, you had one option that we talked about before, was you could use a bunch of references. Use a bunch of reference parameters, and that'll allow you to set things that did not come from your own local variables. That was your first option, but now you can also use a struct. Can return a struct. Or you can use some combination of both. Like you could have a reference parameter that was itself a struct. You do you. Okay, so let's do a few things. Let's make a function that takes a point and does something to it. Alright, so let's say, I don't know, let's make a function that adds 2 points. Why not? So I'll make add, a function called add, that it takes 2 points, point p, or how about, I shouldn't use x, should I? p1, point p2. How about that? And then when it adds these things, we want it to give back a new point. Okay, so the return type as well will be point. So this function will take 2 points. Oops. This function will take 2 points and return back the sum of the 2 points for some good definition of sum. All right, so how about the point that we return, its x value gets set to the sum of the x values of the 2 points that we were given, p1.x plus p2.x. How about that? I'll do the same for y. Yeah. So now if we were given like something simpler than this, let's do, I don't know, point A equals 1, 2, point B equals 3, 4, and then we can say point C, because this function is about to return something, if I actually have it return something. How about that? So now it's going to return this point that it was building up with those two sums, equals add A and B. This will give back a new point, a third point, that I could set to C. Okay, we'll set that into C, and, well, what will C hold but the sum of those 3 coordinates, or those 2 coordinates. So C will become, based on the way we define this function, it'll add the 2 x coordinates. We'll add those 2, and then it'll add those 2. Yeah. So it'll become 4, 6. Now we can confirm that by printing out C in our cool little notation. Okay. So nice. We got a function that's working, and we're returning technically 2 values. We're returning an x and a y. So you can make as big of a struct that you want, and it will be returned. You can return an entire thing of that type, and you could put like 50 things inside of your own struct, and you will be, in essence, returning 50 separate things. They're all just packaged nicely inside of this struct that you made. Okay? So, what should I write here so that we remember what we did? Let's make an add function. Alright, so that's what we just did. And so now we have options. We can return a struct if we want to give back a bunch of values from a function, or we could use reference parameters. I guess I should have that pluralized. Okay, what if you do both? I don't know, how about a negation function? Let's write a negation function that negates all the 2 coordinates of a point. Okay, so let's write this here as well. Let's make some space. Let's make a negate function that takes a point as a parameter, as a reference typed parameter. Point reference. Alright, so this just works as normal. We'll say, well, it's going to be void because it's not going to return anything. It's just going to update its parameter. Negate point reference p. And so what it's going to do is update p to hold negative versions of its coordinates. So we'll say p.x equals negative p.x, and same for y. Okay. And by virtue of using references, that fancy ampersand, I just touched the actual values of whatever I passed along. So let's negate c now. Let's print C back out. Oops, what have I done? Ambiguous. Oh no, there must be another function called negate somewhere. Dun dun dun. Probably in the standard library, who knows? Well, let's call it negate point then. Are you happy now? Yeah. Alright. That'll work. Well, let's make sure this is called negate point then. So it's not called negate anymore, it's called negate point. Because there must have been another one called negate. Okie dokie. So what it's going to do is it's going to go inside of that point C that we had, that held 4, 6, and negate all of its variables, all of its member variables, all of its fields. Do it for X, do it for its Y as well. And so we're going to print out now the new C, which is the negated version of the old one. And let me just refresh your mind as to what's happening with these functions. Let's talk about the stack some more. Let's get that all drilled into our minds. So let's make a blank slide. And let's do this. So down here in main, we had many variables, one of which was our C. So we got a bunch of little boxes for all the variables. We had one that was our C, all right? That held an X and a Y. That was 4 and 6. Okay? And then we called negate on C, all right? But it got past a reference parameter. And so remember what references do. They are aliases for their arguments. So P is a reference to the C that we passed along in that place. Okay, so it's as if we said point ampersand P equals this C. See that? So let me do the thing that I like to do when I draw references. I'm going to use green. Use a different color. There we go. So for negate, you got a P, but that P already existed. It's just another name for this C down here. You see that? So when negate up here says P.x, it's really getting translated into, for main, C.x. And so that's why it's touching these things. It's never, it didn't get copied into some new P up in here. No, negate took a reference to something that already existed. P was a reference to main's C. Okay? That's, I think, what I want to say about that. So you can make as many different structs as you want. You could make a point 3D struct. So instead of holding 2 coordinates, you could hold 3 coordinates, 4, whatever you want. We can now make this student struct. How about we do that? Very quickly. Why not? We could say, no, just do it up here. Or no, let's make a new file. Student struct. You have multiple types, not a problem. We're gonna need strings, so let's put that here. So we're gonna say struct. Well, what makes up a student in your mind? Well, let's see what we need. All right, so let's say student Lawton. What should we know about Lawton? Lawton's graduation year equals 2020. Lawton's, I don't know. What are the things that I said? Well, we're gonna have to have a name. Lawton Nichols, graduation year. What else did we say up here? ID number. Dun dun dun. Lawton's home campus. Clovis Community College. Things like that. So let's store all these things. Okay, so 2 strings, an int, another int, I don't know, Lawton.gpa, I don't know, 3 point, who knows, should pick a random number here, not to look good or bad. 3.33, why not? Just a bunch of 3's. Alright, so what do we have that makes up a student? And maybe instead of calling this Lawton, because it's like it's putting my name as the variable, let's just call it L. Okay. There. How about that? Okay. So are you ready? What order should we do this? Let's just do it in the order we did it. So a student will have a string inside of it called name. And I guess above that I put the graduation year. So int graduation year, then a string name, then, well, it doesn't have to be in order. Let's put GPA next. Double GPA. And you see how the types are working now. Int ID, string home campus, or we just said campus. And now we can make a bunch of different students now. All right, you have your Lawton, you have whatever else you want. Okay, let's print out me. You can print out, I don't know, my name and my ID number. L.name, colon space, L.id. Okay, so these structs can hold as many things as you want with whatever names that you want, and you're just putting all this information together. It's in one big nice package for you to do cool stuff with, to pass along to functions. It's really exciting and it's really useful. Okay? So I hope that you see the utility in this. And boop, easily with just a few dots we can say, yes, we can get out the information we cared about. Alright, so we made our own types now with structs. Isn't that cool? And so we know a little bit about what objects are. OOP stands for Object-Oriented Programming. And we can go deeper than this, though. Let's get into something called classes. Okay, so this is, actually, remember that counter example? I made a class called counter, and we're ready. We're ready to do this ourselves. Okay, so classes are the backbone of object-oriented programming, this thing called OOP, Object-Oriented Programming, because we've got class, we're about to learn it. All right, so classes, they hold data like structs. And they also hold operations. Probably should have used a darker color, sorry. That's still visible, it's just very bright. Data like structs, but also operations on that data. And if you don't like my handwriting, here it is on another slide. This is the key behind object-oriented programming. Okay? So classes equals data plus operations. We had the data in structs. Let's enhance our structs. Okay? Put that back to green for later. So think of classes, these things called classes, as enhanced structs. Boop. So the idea is a class represents an object and all the things that you can do to an object, something that exists in real life. That's what an object is supposed to represent, like a point or a person. So what can you do to some objects? All right, what are their operations? What is their data? Okay, so we had student. That's certainly a kind of object that exists in the world, student. And we know what their data holds, like you got your name, ID number. What are some things? What are some operations on students? This is data ops. What are things that students can do? You can have like dot go to class method. I don't know. Dot graduate method. I'm saying words and I'll explain them later. These are some operations that you could totally do on a student, right? Okay, what else? I don't know. How about a cat class? So what's the data associated with any cat? Well, you get to pick as the programmer what you need to store to make your program run. But how about, I don't know, the name of the cat, date of birth, From that we can calculate the age, so we don't have to save the age separately. I don't know. Favorite food. And the list goes on. And all right, what are some operations that cats can do? Dun dun dun. Op. Well, they can eat. They can eat something. Like, I don't know, some type food. F. They can eat some object of type food. Call it F. They can eat that. They can .meow. That's a total operation that a cat can do. They're good at that. Let's see what else. They can jump pretty high. They can scratch. They can jump onto something, like, I don't know, table tea. And they can scratch. They can scratch anything, but I don't know what we're going to put there. Pick your favorite type. So I hope that these kind of metaphors are making sense in your mind. Like, we can make a type called cat, and we know through structs that we can store all this information about a cat. But the cool thing that classes give us that we didn't have before is operations as well on each individual type, on each individual element of this type. So you can have two separate cats and they can eat different things. They can jump on different tables, okay? They can meow in slightly different ways, maybe. That's the idea. So just as every different point had different x's and different y's, every cat, for example, has its own eat method that you could call to make that particular cat eat. Okay? So let's go back to points. All right? So we've made all these operations. We made a few of them, actually. We've made negate. We've made add. We can make more, like scale. That scales it by some constant c. Like some double. C for scale. All right. Well, the idea is what we used to have was our point P equals 3, 4, for example. And P looked like this in memory. It held an x and a y that were 3 and 4. What we would like to do is somehow make our P not just a data holder, but a data holder and a responder to commands. Okay? So, on our points, to not just hold data, but to also respond to our commands. We're like playing God with these little things that we've made inside of our programs. So inside of each P, it has its own negate. It has its own add. It has its own scale by some constant c. Okay? That's the idea. Like, the functions are built in as well as the values, the data values. And that's what object-oriented programming is all about. Okay? So, before we define this, before I teach you how to do it, let's get some terminology. Okay? So a class is very similar to a struct. It's another keyword in C++, and I'll show you an example for a point. We'll make it a class instead of a struct. It defines a type. But it also, at the same time, defines operations on that type. And that's what makes it cool. Cooler than structs. Okay? This is a super huge key thing. Alright? That's the idea. And so, again, we have this differentiation between the type itself and a value of that type. So up here again, like we talked about already, an object is a value of a struct type. It's also the value of a class type, okay? Whereas the struct is just the name of the type itself. It's point versus P up there, and it'll be the same idea down here. A class is the name of a type, while an object is a value of some class type. So if we made point as a class now, again, we could say point P then P would be an object and point would be the class name. Okay? That's the idea. Point's the class, P is the object. You can have a bunch of different objects of the same class type, P and Q, for example. Okay? So we already know about fields and member variables. To their struct equivalents. But something new happens. The operations that we get to associate with every class, we call those methods, or member functions. Okay? Those are the operations that we associate or give to a class. Okay, so for example, we can make the negate method or member function that works in every point P. Okay? P, Q, whatever. That's the idea. Okay? And then I'm going to give you a very nice example of all of this in just a second. Don't worry. We have to deal with all of these words, unfortunately. We have to learn them. So, the final one is OOP. Okay? OOP, which stands for Object-Oriented Programming, and it's programming with objects. In essence, it's like making a bunch of classes with associated methods and data values inside and using those as much as possible. And the reason this caught on so much is because as humans, we like to think of things like they're entities, they're physical things that we can go and touch. Like this point at something on my desk, and I can press a button that says negate on it, and once it does that, this point has changed into its negated form. Okay? It's like an individual little computer inside of a computer. It can act on its own. Okay? So that's where I want to leave us there with terminology. And now we're ready. Okay? Let's make this point class. We can do pretty much everything that we had already done. I think I'll make this small. I don't know if I want this yet. Instead of struct point and some braces, we're going to swap this out for the word class. Okay? Class point. And again, we'll have semicolon at the very end. And here's what you can do. Class point, it has the same data values. Okay? You can still say double X and double Y. But you can also give operations that live inside of here. You can put functions in here too, as well as variables. Okay? There's one extra thing that we'll talk about later. You have to put this right here. Public, colon, colon. That's key. Just memorize it for now. In a few slides, we'll get to it. Okay? It says public. And then we can give our member functions. So these are the fields / member variables. Let's give our methods now. We can say void negate. And we can go and implement it. Do its thing. We can say, I don't know, void add another point other. Point, I don't know, P2. And give its implementation. It's a function that lives inside of a data type. It's weird. And We'll have to start implementing it next time probably. What next? An add. Oh, sorry, we just did add. Scale. Scale by some variable. We're calling it C. Void scale double C. And we can go and implement that even. ... That's a bad closing brace. So those are the member variables. These are the methods, or the member functions. Okay, so that is a point class. Okay, it's pretty much the same. Remember the public colon for now. I'll talk about what that means in just a second. It has to do with this topic, this idea called access control. Remember the public, and then also remember that you can do the same thing as structs. Put the member variables inside, just like structs, and then put the methods inside the class. Okay? That's so weird that you can put a function inside of a data type that you're defining. And that's the idea. So now, if we go and implement this, and we will totally do it, don't you worry, we can say point P again, and we can even give it values, probably. We could say p.x equals 1, p.y equals 2, and we can print them out as we did normally. But now we also have functions that we can use on it. Okay, and you've seen this kind of notation before, you just didn't know it. You didn't know where it was coming from. You can say p.negate. Okay, we just defined a function on points. Okay, this calls the negate method on p. Okay, it's specific to p's current values. And it's going to negate p's current values. If we had a q sitting around here, it wouldn't touch q, okay? Because p itself has its own version of all of these functions. It's beautiful. You've got your p with its x and its y, and all of its little functions. Then you also have your q with its own x, with its own y. I'm drawing small for a reason. Can't really fit this all. And its own little functions. Negating p calls its version of negate, and it works on its x's and y's. Now we're going to implement this, but I think we'll have to wait until next time. We're running out of time, I think. So that is, in words, how you would start this point class. You can put all the data that lives inside of it, call them member variables. We can put all the functions, the operations that we can use on these points inside of it. Remember the closing brace and that semicolon, that's important. And then we're home free. We can start using these operations, calling these methods on these objects of this type. I think maybe we can get started. I can type this up, oops, and get you to a point for our points. Get you to a point where it's almost compiling, but we didn't implement anything yet. And then I'll have to save all this for next time, okay? Save the rest. So class point, then you have to say public, so our users can actually see this stuff. Has to do with access control. And then we say double x, double y, and then, so these are our fields, or member variables. And then we have our functions. We had void negate, void, oh shoot, do we want to do void? You know what, I think I'll change this to point. It'll give back the new point that we added. There. P2. And what was the last one? Scale, right? Void scale. double C. Okay, so these are the declarations. We can go and implement them as well with dot dot dots for now. And this is what it would look like. And we'd be able to do this kind of stuff. Point p dot x equals 42, p dot y equals 43, as we did before with structs, but now we can also call these methods. On p, we can say p dot negate, p dot scale by a factor of 2, increase everything by 2. So I'll make x to be, I don't know, well, it's already negative, so it'll make x to be like negative 84, right? Negative 86 for y. And we can go and print that out, and hopefully it works like that. So should make p dot x equal to negative 42 and p dot y equal to negative 43. And we can write tests to confirm this. And this should make p dot x now, after it was negative 42, negative 84, and p dot y equal to negative 86. All right, so I'm going to have to leave you on this for suspense purposes, for time purposes. But this is where I want to stop. Okay, this is the base structure for this class. It has data, it has operations. We will define the operations next time. Okay, so I know you want to learn it just as bad as I want to teach it, but we have to wait. So I'll see you next time.